Hello, my name is Beatrix, and I'm the project manager for Artemis at Numena. In this learning series, I will be speaking about the complexity of spatial simulation projects and strategies on validating them, or in other words, strategic validation in complex spatial simulation projects. So all projects start from an initial idea or concept, which can vary on the size of the scope, but once narrowed down, usually feels somewhat manageable. However, sometimes, and especially in spatial simulation projects, which Numena specializes in, once we start building, it becomes apparent that there is more to it than the original idea. Complexities start arising from all angles, and there is actually quite a bit of danger in underestimating this complexity. So there are three very common dangers. The first is losing track of the initial idea. This can happen very easily if the complexities of the project are just so big and necessary to think about that the initial idea almost feels like it doesn't even exist. As you work your way through the project, you might find that there are some assumptions that you were making that were also not true. And as you keep revising your assumptions, you maybe lose where you came from in the beginning. So along with this brings in the question of when to bring in decision makers. When do you call up your boss to say that you can't do what you had originally thought? When do you bring it to the client to revise the idea altogether? It becomes a sort of dance, and it's a really important dance. So the next common danger may become the evolution of the first. But let's say it turns out that there are other elements that are super important for what you were trying to build that you weren't aware of in the beginning. So when you start mapping out and analyzing the project scope, you are forced to expand it. This becomes very dangerous territory as it can throw you off completely and will make you question where the idea even ends and the complexities begin. The third danger is budget. This is all about resources. In architecture and project management, this is known as the scope creep or budget creep. When the client keeps adding to the idea, oh, we also want this, we also want that. This will run into resource management. As with each add-on, someone on the staff actually needs to follow through. This can cause the project to go over budget and be months behind schedule if you don't catch it early on. So even though there may be some assumptions that change, some changes in the scope, and some potential add-ons, it is very important to keep the idea, however it turns out to be defined, very visible, and to make sure to draw each complexity back to it. And that is where you will find the solutions that support the project in the best way. So how do we actually do this in practice? Because complexity can show up in various ways and on different levels of a project. The first step is finding where the complexity actually lives in your project. So now I'll go through two Artemis projects of which Numena is involved in the development. So this first project, we have partnered with the University of Florence to develop a user interface to analyze cracks and pressure points, among other things, for this pulpit made by Andrea Pisano in Pistoia, Italy. It is an ongoing Artemis project, so this isn't a one-to-one representation of the project's complexities, but it's a good example for a scenario of a specific type of complexity that can occur. So a large part of this project includes sensors that are on the pulpit that measure different sorts of data. There are a number of people and teams involved in making this possible and can be represented as personas, as you can see here. Each persona involved either controls a different part of the technology, has a different skill, or has come in with different assumptions. We have the person who ordered the sensors, the person who installed them, the person who maintains them, maybe someone who studies the sensor data, and then we have the person who made the idea of this project, and the person developing the interface, and then of course the user who gets to use a cool web page to learn more about this amazing pulpit. So for this project to run smoothly, we assume and hope that the data or information needed to create the final product will flow through the entire chain smoothly from start to end. But commonly this is not the reality, and instead the chain of people is broken or does not fully exist yet. For example, nobody knows who ordered the sensors originally, and so we can't ask why those specific sensors were chosen. Questions like, is the data live or already collected? What does the data actually look like? Random numbers, or is it structured? What type of sensors are there? How many sensors are there? Who is organizing and processing the data? Who is actually going to send us the data? These become a huge roadblock when the chain does not work properly and answers are not easy to find. And it can easily become more of a guessing game. Now I'm going to move on to a second project to show a different kind of complexity that you can encounter. I will come back to the first project afterwards and draw some conclusions from both examples. So as mentioned before, different projects can bring different complexities and ways of getting lost in them. This is another current Artemis project that Numena is leading. It is centered around the Mértola Castle in Mértola, Portugal. The castle has undergone multiple architectural transformations and changes in control, which reflects its strategic importance and its role in various historical conflicts. An important part of this project for us is to give archaeologists an embodied experience in virtual reality to test current theories of the use of weapons or spaces during a specific battle. So where's the complexity here? In this project, all the simulations depend on one another. This will make the experience really interesting once it all comes together, but can make it even more confusing when it comes to the complexities. So here is the first layer of the simulation that we are creating, the terrain. This seems simple enough, and can be. However, we also need to make sure that we are being as accurate as possible. Obviously, it's nice to have accuracy to prove that the experience is well made, but for the purpose of this particular project, it's even more important. Because we are trying to make this a tool for archaeologists to test hypotheses, this means that even a few degrees difference in the angle of the hill, for example, could determine if it was possible to build a tower at a certain height or not, considering the tools that existed back then. Another layer is the water within this environment. The land sits between two rivers, which is very cool, but can obviously also be directly linked to the strategic placement of the castle. We have to figure out how to make the water look like water, move like water would, as well as making sure that it is historically accurate to the time. Questions around erosion, for example, come up. Were the rivers as big as they are today, or have they expanded in width over time? Are they in the exact same position as they were, or have they moved over time? Vegetation is another layer. Trees, bushes, rocks all interact with the water and the land. This, again, is very important to get accurate and relevant to the overall simulation. There are the general questions like, the trees need to grow upright, not sideways, even if the ground is slanted. They need to grow in realistic areas, so not growing out of a rock. And then what specific plants grow in this type of environment? Who is 3D modeling the plants, and in how much detail? Do they move in the wind? And then we also have to find the accuracy for the time period. If the environment was heavily forested, for example, in the time of the battle, this would drastically change the possible strategies of attack compared to if there was very sparse vegetation. And what about how the season affected the vegetation at that time? Now we have the actual castle structure, which is maybe the biggest component of this project. And just like everything else, it needs to be accurate to the time of the battle. So that's things like the stones that it's made out of, the thickness of the walls, the height of the towers. Were there specific defensive and offensive features that played a role in the battle? For example, we know at one point that the castle featured a bent axis main gate to bottleneck intruders. These can all play huge roles in a time of conflict. Now on top of this, we have the battle. This is another big layer to the simulation, but this is a great opportunity to challenge current theories of battles. Being able to see the actors involved in the physicalities of the battle and how they interact with the site can be very valuable and likely would bring new perspectives to certain theories. Along with the people and the horses, we need shooting cannons and other weapons that were around at the time of the battle, and then to figure out how these interact with the battle, the people, and the architecture itself. For example, how would a cannonball interact with the type of stone that the wall is made of? So already this is a lot. All the simulations that fit into the exact time period of the chosen battle. But this isn't all that we need to think about. To have information on all the elements of the site and the castle of the time of the battle, all the history before that exists too. If a new tower had been built just before the battle, Was it built on top of what had already been there originally? Why did they change it? There is so much information held in every component and change of the site, and we need to know as much as possible of this to be able to paint a full picture for the users. As well as the past versions of the castle and environment, there's also what we have today. Perhaps looking at how a wall has crumbled over time, and the site today could line up exactly with what happened in the battle. We really don't know what piece of information could help with testing out theories before it all comes together. Which is the perfect segue into the knowledge base layer. This is where all the information that we can find about the site, the castle, and the battle is stored. We need this information to be accessible from one place so that users can actually look at it, which is also, of course, a huge goal of Artemis as a whole. It is exactly this information and detail that archaeologists don't have the resources to engage with in their regular studies. And this could mean that they got something wrong because of this typical lack of information. And finally, we have got the final layer of the complexity for this project, which is the linking of all this information. This means that certain elements that were not thought to be related could actually be revealed, which could completely change what we thought we knew about the site, the castle, or the battle. So why does any of this matter? Even though these are different projects and they hold different complexities, they have the same problem, and that's validation. How do we actually know if and when we have succeeded? Well, validation requires setting boundaries. But with so many moving parts and so much complexity, identifying those boundaries is a major challenge. The key is to stop trying to navigate back to the idea from within the complexity, and instead to start from the idea and then pull in each piece of complexity one at a time. So let's go back to the first project. Instead of asking, is the sensor data connected to the interface in a good way, which starts from the complexity, we can ask, can a user find the sensor data they need, which starts from the idea. If we use our persona chain and start from the end, which is the user, then we can work backwards from there. Because it's really how the user experiences the final project that drives this idea. This allows us to come up with simple questions like, what do we want this button to do? And this pulls everyone back to the original idea. It helps the development team figure out what questions they need to ask, and it helps the people behind the idea understand what information they need to provide and why it's so important. So what about this project? How do we get back to the idea here and not get caught up in all the complexity? Once again, we need to try to isolate the original idea. We want to give archaeologists an embodied experience to test their theories during a specific battle. So the validation can be this simple. Can an archaeologist stand in this environment and test their hypotheses? And do they have the potential to prove or disprove these theories? If we can answer these with a yes, then we have done our job. So wrapping all of this up into some takeaways. As we've seen, it all depends on the project, its type of complexity, and where that lives. But some good strategies that we try to follow are the following. Map your actors and data flows before you build, so know who controls what, and you may even be able to predict where the chain might break before it becomes an issue, and then you can try to mend it before it holds up the project timeline. Find where your complexity lives, so is it in the information chain, in the simulation layers, or somewhere else entirely? Start from the idea, not the complexity, so when you get lost, try to get back to the original idea and work from there. Specifically, try your best to approach each part of complexity from the idea and not the other way around. Be the end user and ask the simple questions. So what do you want this button to do? Cuts through complexity faster than technical deep dives. Then we want to define what you're validating early. So you don't need to figure everything out, but write down a few questions that connect directly with the original idea. This can really help remind you further down the road what you are actually trying to achieve. And finally, budget for complexity work itself. Even though we are trying to avoid getting caught up in the complexity, it is most of the time inevitable to a certain extent. Getting back to clarity takes time, and it's easy to underestimate the time that this takes. So that's all for this presentation. If you found this interesting, this is exactly the kind of work that we do at Numena. So if you want more examples of these types of projects, I encourage you to take a look at our website.
And please also feel free to get in touch with us. Thank you.